Okay, so the next thing we want to do, now that we know what classes are, we want to talk about inheritance in Java. And the purpose of inheritance is it's a technique for creating a new class from an existing class. So basically, if you had a class that already existed, and you liked the data that's in that class or the methods that are in that class, and you wanted to create a new class, generally a class that's more specific version of an existing class. Rather than create a brand new class and copy the data and all the methods over and then add more stuff to it, what you can do with just one sentence, you can say, I want to inherit from it. So what you'd end up doing is, let's say you had a class that already existed, a public class called base. And the class you're inheriting from is typically referred to in the literature as the base class. And the one you're creating is the derived class. So the class is derived from a base class. So if we had a class, base, which had some stuff in it, we could create a new class called a derived class by saying that that class we use the keyword extends, and then the name of the class. And the idea is not to just copy it completely and leave it alone. You would then add more stuff. So, for example, for example, would it ever make sense to extend a class and then not add more stuff? What would you be effectively doing if you did that? If you had a class derived which extends base, that means you get all the storage and methods of base, and then you don't add anything.
Copy the class.
You just and you have another name for an already existing class. You really didn't do anything. So the key is, I guess, to add more stuff, and the more stuff will make the class you're inheriting from, the base class, more specific. So, classic examples might be like the base class could be like an animal, which is kind of vague, and then animal would be kind of vague. And then, like a dog is a specific type of animal. So it would inherit all the attributes of an animal and then have more stuff that is specific to a dog. And then you could, and then you could, and make it a cat, which also inherits from an animal and that has things that are very specific to a cat. Okay, so we talked about a method called a constructor in a class. And the constructor is a method, he said, has the same exact name as the class. Same exact name as the class. And then it runs, remember when it runs? Anyone remember when the constructor runs? So the constructor only runs when the object is being constructed. And you can't just call it explicitly, say, oh, I think I want to run the constructor again. You only run it when the object is being constructed. Okay. So the question is, if a class extends another class, and you go and you create something of the derived class, we're going to really have two constructors running. We're going to have the constructor of the derived class and the constructor of the base class. And I guess the question then is, in what order would they run? The order in which they run is going to matter. So if you were designing the language, which one would you have run first?
Base.
And yeah, I mean, obviously, would you ever want just one to run? Would there ever be a reason to just let one run, like one trumps the other one? So.
I think that would be the ideal situation. You want to create, it seems like it's very resource intensive to use the same constructor twice.
Well, it's almost like the constructor of the base class. So really, like what we were saying, when we run a constructor, when you create an object, you get storage. And the storage will be filled in with default values. If you don't like the default value and want to change it to something else, you can put it in your constructor. Here's what to change it to. If you're happy with the default values, you don't even have to supply a constructor because the compiler will give you one for free. It's the one that fills in all your data with default values. So now if the derived object should be aware of what all the fields are. We might say, let's require the derived one to fill in the base one. Or we could say, why don't we let the base one get implicitly called, and then the derived one would be called. So it is a little bit debatable. Should we let the constructor of the derived one trump the one of the base class? But what the creators of Java decided to do was, the first thing that happens when the derived constructor runs, the very first thing is that the base constructor runs. Even if you don't tell it to. If you don't tell it to, the very first instruction is your derived constructor not calling the base one will be called implicitly, not explicitly, not because you said so, but implicitly. So what would happen is, in this case, so here's one thing, I just kind of threw this in as a side example. In this case, I have two constructors in the base. A constructor that takes no parameters, and a constructor that takes an integer as a parameter. So if somebody was to create a base object and give it an integer, like 4, they could, like here, like 4, that would call this constructor and therefore not this constructor. So the rules are for constructors of derived classes, you can explicitly call the constructor of the base class and pick which one you want. By putting a number 4 here, you're saying, I want to run this one, and therefore not this one. And then the next thing that's going to happen is whatever instructions come after the call to the derived, to the base class. So if we were to create a new object, D, the output of this would be, hey guys, you mind talking about this stuff after class? Thanks. So the output of when we go to create a derived object, the output would be first a call to the superclass, and the one that takes in an integer. And then say base integer, which would be the output from here, and then it would, after that it would print the word derived. Okay, so suppose we explicitly call so this is almost the same exact example, except we're explicitly calling the superclasses, which is the base class, its constructor that takes no parameters. Okay, so in this case we're explicitly calling this constructor, the one that just prints out the word base. So the output would be base and then derived. And then if we don't put this in at all, if we don't put this in, the compiler will put it in for us. So if we left it blank, you may not see it, but there's going to be, the very first line is going to be a call to the super constructor with no parameters. So this one won't be called, and then only the one with no parameters will be called, because you didn't call. So it's just good to know, if you don't call one, you're going to get this one on purpose. And if the creators of this class have these for a reason, you might need to know about that and explicitly call out. So it's just good for you to know. So, yeah, the output of this will not be just the derived constructor running, but it will be the base one followed by the derived. Okay. So then there's it's an actually very big class, and maybe we could all spend a whole lecture on it. Java gives this class called object. They supply it to you for free. And if you create a class that does not inherit from any class, you may not realize it, but you're actually inheriting from this class that Java gives called object. So these two classes are identical. This is public class base, and you have some base stuff. And this is public class base, which extends from object, and you have some base stuff. Well, you extend from object if you don't extend from any class. You therefore extend from object. So everything inherits from this class called object, which is a bunch of real vague stuff about storage. But it does things even like, well, later on we can get into multi-threaded programming, where you can create an object and have it run on 2 different threads on your machine, and methods that can do that stuff, interact with the operating system, actually appear in this class object. So you actually get a lot of stuff out of object. So anytime you don't inherit from a class, you automatically inherit from object. And if you do inherit from a class, that one will have inherited from object. Or inherited from something that inherited from something that inherited from something that eventually inherited from object. So everything will eventually inherit from object. Okay. So now we get into the topic of, since inheriting means you get storage from one class and methods from one class, and then you can start adding more storage and more methods, it's possible the names will overlap. So, for example, functions, actually that's kind of a leftover word from C++, it's really methods. But in C++ or Java, the signature of a function or the signature of a method is actually the name of the method combined with the parameter, the types of the parameter list. So two methods have the same exact signature if the name of the method matches and the parameter types match. So for example, add numbers. Let's say there was a method that takes in two numbers, adds them together, and tells you what the result is. And one of them takes in an integer by the name of A and an integer by the name of B, and another one has the same exact name, add numbers, but takes in an integer X and an integer Y. These both have the same signature. Their names match, and the types of the parameters. They both have two parameters and they're both integers. They match. Now you could, later on, we could have a problem where if we had add numbers, integer and integer, and add numbers, float and float, and we called it with a 3 and a 4, you don't know if you're calling the integer one or the float one. That could cause some confusion. Okay, so if two methods have the same exact signature, and what that really means is from the caller of this, you can't tell, you couldn't tell if you were calling this one or this one, because all it's doing is it has the method name and it's looking for two numbers as input. Can't tell the difference between A and B and X and Y. An example of, even though the parameter names don't match, the types match. Here's an example of if we had add numbers with A and B, the signature does not match integer add numbers that takes A, B, and C. So if you were to call either one of these, if you passed in two parameters, you know you're calling this one. If you passed in three parameters, you would know you're calling this one. So those have two different signatures. Okay, so the idea of overriding in inheritance, this would be a case where you have an integer value and a public method called getNumber, which will return the value of that number. Then you create a new class called derive, which extends base. So that means because you extended base, you get this integer, and you also get this method called getNumber, which will take this integer and return its value. Now we add more stuff. What do we add as more stuff? A piece of storage with the same exact name. So now we have two copies. We have the number we inherited and our own number. So we have two numbers. Two integers, both with the name number. And then we have public, we have a method called getNumber, which returns an integer. And this is a getNumber, it doesn't take in any parameters.
Should there be a parenthesis?
Yeah, I was just thinking there should be parentheses. So, so getNumber should be like this. Yeah, because we're looking for right, like that. Okay, right? So yeah, so the important thing you're looking for is do the names match and do the parameters match. So this is getNumber and has no parameters, and this is getNumber and has no parameters. And they both return the number that corresponds to them. And then suppose, okay, so now the thing is this, if I was to create an object of type derive, and I was to call that object's getNumber method, which would it call? Would it call this getNumber that has no parameters, or would it call the other one inherited, which has no parameters? And if you were designing the language, what would you do? Would you say compiler error? I'm confused. You know, the compiler can say, I can't tell what you're trying to do, so I'm going to make you spell it out. I'm going to make you change the name, or would you let the names match?
No, it would make sense to call the derived one, because that would be more specific.
Right. Yeah, and then the other thing is the derived, let's say the derived one needed to get some data out here. The derived one could call this one. So actually what they end up doing, there's probably a couple of choices. One was to say, make it a compiler error and don't allow method overriding. You can't give the same exact name with the same exact parameters, it causes too much confusion. But what they decided to do was to call the derived one and give the derived one the ability to call the other one. And you can call it by using the keyword super again. You could say super dot number. So if this one wanted to call this one, it can. And also, if it was public available to the outside world, you could call it by using super too. So if we wanted to have this derived class return this number and not this number, we could write a method, let's say called getSuperNumber, and then it would return the superclass's number, which would return that number. So actually, even though the names match, you actually get two separate pieces of storage. So if you're trying to count up how much space you're taking up two pieces of storage, not one. And the only way to get to it is to refer, you're always referring to the derived class variables if they match, unless you say super in front of them. Okay, then there's the idea of method overloading. That is where you have the same method name, but different signatures. So for example, we could have in our base class add numbers, which takes in two numbers and returns those two numbers put together. So maybe we're making like a library of math functions, and then someone comes along later on and says, oh, it'd be nice if we had an add numbers which takes in three numbers and tells you what the result is. So we write the same exact method, add numbers, but we take in three inputs, and it returns all three added together. So if we created a derived object, and then called the derived object's add numbers method and gave it two inputs, it would know to call this one, because that's the only one where the signatures match. It would call this one, add the two numbers together, and return a result. If we took the derived object's add numbers with three parameters, it knows call this one, not this one, and it would return these three numbers added together. So when you have, when we're doing what's called method overloading, we're taking the same name but giving different versions of it. It'll be because the list of parameter types are different. And the way you tell which one you're calling is based on what you give it as parameters. So like I said, if we had an integer and we had another method with a float and you called it with an integer, since all integers are floats, but not all floats are integers, you wouldn't be able to tell which one you're calling. So that could present some confusion. Okay. So just because there's a difference between inheriting and a class being composed of something. So for example, suppose we had a fraction. So a fraction is something that has a numerator and a denominator. And just as an example of where maybe a constructor comes in handy, might be, let's say we had a fraction which has a numerator and a denominator. What would we do if we created a fraction and didn't have a constructor? The numerator would default to 0, and the denominator would default to 0, right? So do we like the idea of a numerator and a denominator defaulting to 0, or would we like to have a different default value? So since denominators are what we divide by, it might be dangerous to create an object, have its numerator and denominator default to 0, and then go use them later. We might forget to set it to something. So it might be safer to say, all right, a default fraction is something, you know, probably the value should be 0 by default, but the denominator should not. And we'd like to have the denominator to be something that won't affect anything, so maybe we'll set the denominator to 1. So here would be an example of where we might want to have a constructor for the fraction class. This should extend, sorry about this. Oh, no, sorry, it doesn't extend, it's composed, I'm sorry about that. This was fine the way it was. Okay. So yeah, so real is a class that does not extend fraction, but it's made up of a fraction. So we have an integer part, and we have a fraction part. So like 3.5 could be a real number. So this is like kind of a goofy way of having a fraction, but we could do it this way. I'm sorry. Goofy way of having a real number. So we can have the real number, and then the fractional part, and then put the two together. And we say, okay, the default for the real number should be 0. And the default for the fraction, we're just going to let the fractional part call its constructor. So if we were to go to make a real, how many constructors would be called? So here's the thing, real doesn't extend from fraction, but it is composed of a fraction. It has an integer and it has a fraction. Put the two together, that's a real. So now we're going to make a real. So we have to get storage for this. We have to get everything from what is composed of. So if you were designing language, which constructor would you have running first in this case? I guess, it's kind of good if intuitively, you know why. Yeah?
The real one?
Okay, well, so one thing is for sure, the constructors, two things happen during construction. One is you get storage, and another one is a method which has the ability to alter that storage. Right, so of the two steps, getting storage and writing the code that could alter it, which would be done first? And suppose we didn't have composition. Suppose we didn't have a class that is composed of items from another class, and all you had was storage. So suppose we only had the integer part. Would you get the storage first and then run code that could change its values, or would you change its values first and then get the storage set? The change would come first or second?
First.
Well, no, the storage would have to be there before we could change the values, right? So we'd want to get the storage first, then run the code that could alter it. So now, what is our storage in a real class? So it's kind of good just to think this through, because it might sound, you might want to do the constructor first and then go and make the other objects. But what we're basically doing is getting the storage. Then once we got the storage, then we can run code that could alter the storage to however we would like it. So in this case, what we'd end up doing is we would create an integer, and then we would create a fraction, and then we would run the code that might change the integer or change the fraction. So in this case, this constructor would run first before our constructor runs, because our constructor runs after all the storage is got. Okay, so now suppose we had 3 classes. We had double and triple inheritance, double inheritance. So suppose we have a class A, which has a constructor, right? The constructor is the method that has the same name as the class, and all it does is print out an A. And then we have a class called B, which extends A. So B gets everything A has, and all it has is one method. So B gets everything A has, and plus it could add more stuff. And B added a constructor. Well, B actually did 2 things. One, so this is a combination of inheritance and composition in one. So class B has an A in it, and also has a constructor. So it has an A object in it, and then has a constructor. And then class C extends B. So it has everything a B has, plus more stuff. And what is that more stuff? It throws in an object of type B and a constructor which prints out the letter C. So yeah, so then this answer is not E. So what would the output be of creating a C object? So the output of creating a C object would be, the first thing the C object does is it creates a B. And the first thing a B object does is creates an A. So this constructor would run first. And then the constructor for the B object would run, which would run the A's constructor and then the B's constructor. And then the B object would then get created, which would run the A constructor and then the B constructor. And then the C object's constructor would run, which would then run the A's constructor, the B's constructor, and the C's constructor. So it's just a little, that's always a popular question, the order of constructors being run, when you're inheriting and composing. And yeah, I have some coding example of that, but okay. Yeah. So now in I guess C++, the popular predecessor to Java, there was the idea that you could have a class that has methods in it, and the methods would have no body. So who's ever inheriting from it would have to supply a body for it. And those are sometimes referred to, those classes were sometimes referred to a class that is only used for inheriting from, but never to make an object from it. So Java made it a little bit more explicit, and they basically have a definition of what an abstract class is. So an abstract class is a class that has at least one abstract method. An abstract method is a method that is declared only with its signature, and it has no implementation or no body to it. It's just open parenthesis closed. Since the class has at least one abstract method, nobody could ever create this object, because if you went and call that method, the compiler wouldn't know what to do. Actually, it would be doing nothing. That would be defined as an abstract method, and therefore it'd be dangerous to create an object and call that method on. So then classes and methods that are considered abstract are used. You can explicitly call them abstract with the abstract modifier. Okay, so for example, suppose we wanted to have a class, let's say we were making a bunch of electronic products. And the actual products we're going to make are going to be like, clocks and radios and DVD players and TV sets and that kind of thing. So when we actually go and create them, we're going to make them as, clocks and radios and TVs and that kind of stuff. We're never going to actually create something called an electronics. But maybe all the electronics we create have some things in common. So it might be a good idea to create an abstract class, a class we will never actually create an object of, but it's good to have the class anyway, so all our other classes can inherit from it. So we would create this class, and we'd say public, and this is one thing new that Java added C++ didn't have, is you would actually say this is an abstract class. What that means is nobody could ever create one of these. If anybody ever said electronics E equals new electronics, there'd be a compiler saying you can't create an object from an abstract class. But we still want this because all our other classes should have all this stuff in common. So for example, we could have a serial number, or a serial number counter, starting at the number 0. So we could have a static variable. If you remember, static variables are shared by the class. All the objects share the same variable. They don't get their own personal copy of it. The actual serial number, we don't have it as a static, so each object has its own serial number. And then maybe we have a constructor. And what does the constructor do? It takes the static counter, increments 1 to it, and assigns it to the storage. So that way every product we ever make has a unique serial number. And then, we could print out this is the constructor. And then we could have other methods like print out the serial number. So now, this class can be used to inherit, other classes can inherit from this. And therefore, every object will have the serial number counter and its own serial number and a constructor for it. And this is how we're gonna have all our electronic products have something in common. And if we had other things like the company logo and what to do when you plug it in and display the company name and count to 10, we could put all of that stuff in here, knowing that nobody will ever create one of these objects, but this will be used to inherit from, and then the classes that inherit from this would pick all of this stuff up. Okay. So, so maybe I just thought I'd go over some examples of who does this. Okay. So, hope this comes out clear. Let me just zoom in. Hopefully it'll come out a little better. Okay. So in this example, we have, so it's just kind of the examples we just went over in the slide, but we could actually just run the code then. In this example, we have base class, which extends object. So what is the point of saying extends object? Well, that could be like a silly, I don't know, almost trick question in Java. If you have a class that extends object, what is that the same as?
Saying nothing.
Same as what?
Same as saying nothing at all.
Same as not extending object, because if you don't extend object, it's going to extend object. So this is really pointless. Extends object. So I just thought I'd throw that in. So that lets us know base doesn't inherit from anything, but if I didn't put that there, it still wouldn't inherit from anything. Okay, so now, yeah, I'm printing out the base constructor with no parameters, and then I have a base constructor with an integer. And I have a base counter, which is a static variable, so I can increment that by 1, and then print out its value if I want. And then I have a derive class, which extends base. And then derive also has 2 constructors, one with an integer, one without. And so that all the constructors do is increment the counter and then assign the new value and print them out, and then I could call the derive count, and if I wanted to print out the value, I could print out the super's value and my own value, the derive class's value. So this is the class base derived value. So sorry, I'm no longer resting. Yeah, so in this case, we created we ran the base constructor that had no parameters. The base count went to 1, and the value was hit at 0. Then we created one where we called the base object we created, we passed in a value, so we knew we passed in the integer base constructor. The base count went to 2, and the value of our object was at 2. Then we called ones with no parameter again. So we got the base constructor and the derived constructor, the ones with no parameters. We had 3 base objects, one derived, the count on one derived one was 1. And so, so this counting value is the next one, the value to be assigned to the next one that gets created. Because we increment the number before, we assign them the value over and then we increment by 1. And then when we went to create the fourth one, we called the derived one with 2 digits. It was our fourth base item, our second derived item. The base value was set to 44, and therefore we didn't call the constructor for, I'm sorry, the derived value was set to 44, and we didn't call the base value, because we passed in the integer 4. Let me see, so I have a couple of other examples. Constructors. Okay, yeah, the one on the order of constructors. This code. So this is the code, this came from one of the slides. So here's where we had a class called A, as a constructor that prints out an A. Class B, which extends A. So not only does class B extend A, not only does it inherit from A, it also is composed of an object of A. And then C extends B, meaning it has everything that a B has, plus it has whatever it adds to it, and it happened to add a B. So a scenario like this probably wouldn't come up in the real world, where you're inheriting from something and then also being composed of it. But it just gives an idea of what's going on with the constructors. And then I just put some print lines to make the output look a little nicer formatted. But I created an object of type C by calling the constructor of C and assigning the data that returned from it to the object C, which is of type big C, and let it run. So when we let this run, we compile it. This is called constructors. Okay. And then we let it run. And so then the output is, I don't know if this is picking up on the camera, but it's A, B, A, B, C. Anyone want to take a chance on explaining? So an object, okay, so we go to create an object of type C. In order to create an object of type C, what is an object of type C? Well, it has a B in it, and then it also has a constructor to it. So all it really has is a B. What is a B? A B is something that has an A, and it also has a constructor. And what is an A? An A is just a constructor. So when you go to create a C, you, by nature, create a B. And what is a B? Well, a B is an A. And then we actually go to create the A, and when the A runs, it prints out A. Then we need to finish creating the B. So right? So does that make sense? I know this is like this is more of a brain tease. This will never come up in the real world. But so what we're doing is we're creating a C, which is made up of a B. What is a B? It's a thing that's made up of an A. So we go to create the C, which the first thing we're going to do is create the storage before we run its constructor. So to create the storage, we have to create the storage for an A before we run the constructor for B. And what is an A? An A is nothing but a constructor, so it just prints out the letter A. So when we go to create the C, it creates a B, which creates an A, and then the constructor for A runs. So that's this first thing. Then what's the next thing that happens? Now that the storage for B is done, we have to now run the constructor of B First thing the B does is create its storage, then runs its constructor. What does its constructor do? It implicitly calls the constructor of A that it inherits from, and then calls its own constructor. So it will call A again and print out A a second time. And then it will run the constructor of B, which prints out B. So now we have successfully completed the B part of creating a C. I'm sorry, we correctly, created the B part of the C. Now, what's the next thing that we have to do? Well, C decided to add in a B. It makes an object of type B. So to make a B, we would call the constructor of B, which is going to first call the constructor of A and then the constructor of B. That's where the A, B, so that's where the A comes from creating the A object. And then the A and the B, that's where this call to A comes from. And then we can finally call the constructor of C. Now that all the storage for the C has been created, now we can call the constructor of C. And the constructor of C, before it even starts, will inherently call super C, which is B, and before that one even starts, it will call super B, which is A. So then it'll then call A, B, A, then B, and then C. Yeah, so this one, I don't know, I hope the camera picks this up, but, so yeah, I'll just read what the code is saying. We have class A, which prints out the letter A. Class B extends A and prints out, class B extends A and also is composed of an A, and then prints out, its constructor prints out the letter B. And class C extends B and is composed of a B and then also prints out the letter C. And then we'll go and make a C and see what happens, and it comes out to A, B, B, C. Okay, again, so this is just like a brain tease on the order of which constructors are called. So it's base classes up through derived classes. That's the order of which they are naturally called. And if you start putting in storage of other classes, the creation of those objects happens first. The constructor of your class runs at the very end. After you've gotten all your storage together, you could then run your constructor to change the storage again. So the purpose of the code in the constructor is to change the storage you have, if you don't like the defaults that you have.